We're going to start our next unit, and it is on exponent rules. So I want to just review with you what an exponent is. We've been talking about exponents since the 6th grade. So if I have x to the y, keep in mind that this entire thing is what we call a power, where x, which is our big number or letter, is our base, and y is our exponent. And this is the only time that the little guy tells the big guy what to do. So if I give you 2 to the 4th power, this little guy, the 4, which is the exponent, tells us to write 2 times itself 4 times. So those are the things that we're going to be looking at, and we're going to be looking at how we can simplify exponents today, and then we're going to go into add, subtract, multiply, and divide, and the rules that go along with that. So we're going to look here at, we have an iceberg. An iceberg is a large piece of freshwater ice that is broken off from a glacier ice shelf and is floating in open seawater. They are classified by size. The smallest is called a growler. A growler found floating in the ocean just off the shore of Greenland. Its volume above the water is approximately 27 cubic meters. So what they want us to do is, if we have 2 icebergs float near this growler, one has a volume of 3 to the 4th times greater than the growler, and one is 2 to the 8th times greater than the growler, which has a larger volume. Well, we can take these powers and we can expand them. 2 to the 8th is going to be 2 times 2, 4, 5, 6, 7, 8. And we can go ahead and then simplify that. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. 4 times 4 is 16. 16 times 4 is 64. Times 4 is 256. So you can see, in fact, that this one is larger. What is the meaning of 3 to the 4th and 2 to the 8th? Why do you think exponents are useful when writing numbers? So exponents are a way to represent repeated factors. So just like in elementary school, when you learned about repeated addition, you can write it as multiplication. If we have repeated multiplication, we can write it with an exponent. Suppose the original growler's volume under the water is 9 times the volume above. How much of its ice is below the surface? Well, if we go back up here, we had 27. That was the original, and it is 9 times that. So 27 times 9 is 243 cubic meters, because they gave us a unit there. Then we can take this information and we can write it using powers. So we want to write it with a power of 3. The volume above the water times 3 squared. Well, we know that 3 squared is where we get that 9. We break it down, and that'll give our volume to the surface. So if we go to 27, we want to write it in terms of 3. Well, we need to figure out how many repeated 3's will give us 27. Well, we know that 3 times 3 is 9, and 9 times 3 is 27. So 3 to the 3rd times 3 to the 2nd. If we expanded that, 3 to the 3rd here, and then 3 to the 2nd here, I can see that I have 3 times 3 times 3 times 3 times 3, which is in fact 3 to the 5th. And if you were to use your calculator, 3 to the 5th power would in fact be 243. So if we look at this, what relationship do you notice between the exponents on the left side of the equation, meaning the 3 and the 2, and the exponent on the right? So on the right we have 5. Well, we know that 3 plus 2 is 5. So right now it looks like if we add our exponents, we should be okay. Let's see if that continues to work. We're going to look at a couple of examples in doing that. So use the table below to help verify the pattern that we noticed. So the one we just talked about, does it work if we add them to get that final exponent? And And so we're going to write our expanded form here, and we're going to see what we end up with. So you can see here, 2 to the second power is here, 2 to the fourth power is here, 1, 2, 3, 4, 5, 6, and in fact, 2 plus 4 does give us 6. So we could even write it, sometimes you'll see it with an exponent of 2 plus 4. So here, 5 to the third is 5 times 5 times 5. And then we have 5 to the second, 5 times 5. So there's my 3 and there's my 2. So essentially I have 5 to the 3 plus 2. Well, 3 plus 2 is 5. So now I have 1, 2, 3, 4, 5. So when we add our exponents, you should get your single power. You could list all your x's, or we can just write the simplified rule. X to the 4 plus 7. 4 plus 7 is 11. And a to the 6 plus 2. 6 plus 2 is 8. So the rule is what we're going to write here. Based on the pattern, write the missing exponent in the box. And this is called the product of powers property. So if we have a to the m and we have a to the n, we can take a to the m plus n, and that will be our rule. Okay? Meaning, as long as you have the same base, so the key here is that you have to have the same big number or letter. You have to have the same base in order for this to work. We can make a little note of that. So we can apply this even with fractions. So I have x to the 3/4 plus 5/4. So we know from 6th grade that in order to add fractions, you have to have a common denominator, which we do. So 5 plus 3 is 8. Keep the denominator, and I know that 8 over 4 is 2. The density of an iceberg is determined by dividing the mass by its volume. Suppose the growler has a mass of 59,049 kilograms and a volume of 81. And you can see this formula over here. Density equals mass over volume. Compute the density of the iceberg. Well, if density equals mass, so we're going to write 59,049 over volume. I will tell you, and I don't have my calculator right here, but you can put that in the calculator and you will get a density of 729. And this would be kilograms per cubic meter. So we can then, even when we talked about multiplying a minute ago, dividing, we can also find this rule. So mass over volume, and we're going to write this as a power of 9. Well, 81 is easy. We know that 81 is 9 to the second power. 59,049, we could use in our calculator 9 times 9 times 9 times 9. I'm going to tell you it is 9 to the 5th. 729, 9 times 9 is 81. 81 times 9 is actually 729. So what is the pattern that you notice now? Well, hopefully you notice that if we subtract our exponents, we will get a single power, because 5 minus 2 is in fact 3. If we wrote this out as a fraction, 9 to the 5th over 9 to the 3rd, well, I know that 9 divided by 9 is 1. 1. 1. 1 times 1 is 1. And then I have 2 9s left, which would be, I'm sorry, I wrote too many 9s here. I apologize. I got a little bit 9 happy. 9, it was only 9 to the second, not 9 to the third. Let me fix this. So there was just a 9 here. So 1 times 1 times 9 times 9 times 9. 9 times 9 is 9 to the 3rd power. Sorry about that. So then we can practice some more to see if this does in fact match the rule we just said. And you can see here that they've listed them out, 2 times 2 times 2 times 2 times 2 over 2 times 2. And we know that 2 divided by 2 is 1 and 2 divided by 2 is 1. So we're left with 2 to the 3rd power. We don't need to write this 1 because we know 1 times anything is that stuff. So we can do the same thing here. We can say 5 times 5 times 5, that's 4 5, 6, 7, 8 over 1, 2, 3, 4, 5, 6. And I know 5 divided by 5 is 1. 1, 1, 1, 1, and 1. And I'm left with 5 to the second power. Well, let's think about this. If we write our rule, we said 8 minus 6. Is that 2? Yes, it is. We can do that. It doesn't have to be numeric basis. It can be variable basis. A to the second. Because again, 3 minus 1 is 2. Notice also that the numerator is the first number in the subtraction and the denominator is the second. Also, notice that all of the bases are the same. So 7 minus 3, this should give us x to the 4th. You can write that out if you would like. So then what would be our rule based on the pattern? Right, the missing x. So this is called the quotient. Quotient is division of powers property. So m over n becomes m minus n. And again, must be like bases. You cannot do this for, say, 3 to the 5th over 4 to the 2nd. Okay, you can't do this rule with that. They have to be the same big number. We can do the same thing with fractions just like we looked at a minute ago. So if the rule is subtract 11 thirds minus 2 thirds, and again the numerator is first and the denominator is second. I know that 11 minus 2 is 9 thirds, which is a to the third. So we can take and put these all together. So notice that here our bases are the same, they are x's, but now we have some coefficients. So we're not going to worry about what they've got here. We're going to come over here and we're going to write this out ourselves. So I'm going to say 2, x to the 5th means x, 2, 3, 4, 5 x's. And then I have times 5, x to the 4th is 4 more x's. Your coefficients or your regular numbers, you're just going to do normal math with that. These are being multiplied. All of this is multiplication. So we can rewrite this as 2 times 5. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9 x's. Or if we wanted to use our rule, x to the 5 plus 4. We're multiplying, so we add. Simplify this, 10x to the 9th. So again, coefficients are just going to get multiplied. And then you'll add your exponents. I would like to do one more example with you. Example B. And again, I'm going to go ahead and write it over here. I'm going to go ahead and expand this to x to the 5th, 3, 4, 5, y to the 4th, 1, 2, 3, 4. Now again, this is what I was talking about. These don't have like bases, so you can't say 5 plus 4 here. X is down here by itself. If it is all by itself, it is a power of 1 because we don't write that, and y squared. So I can see here, these x's are going to become a 1. These y's are going to become 1 because when you divide anything by itself, that's what you get. So I have 2, and I have 1, 2, 3, 4 x's, and I have 2 y's. Now, if you wanted to write that with the rule, we know that when we're subtracting, I'm going to go ahead and write this part over here. We have our 2, 5 minus 1, and y to the 4 minus 2. And we know that 5 minus 1 is 4, and 4 minus 2 is 2. So we get the same thing. So if you're feeling comfortable with the rule, go ahead and use it. Otherwise, you should probably work on expanded form. I would like for you to try A, B, and C. So if you would pause the video and then come back, I'll talk you through those because you're going to have an assignment on this when you come to class. So I'm going to work on A over here. A, we're multiplying, so 4 times the negative 2. This is a 1, so I have x to the 1 plus 2 because these are being multiplied, y to the 4 plus 5, And then I can go ahead and simplify. 4 times negative 2 is negative 8, x to the third, y to the ninth. B is division. So we have 2 over 4. I'm going to have to write that separately. Over here, I have a 1 on my A and a 1 on my C. And I'm dividing, so I'm going to subtract 2 minus 1, 5 minus 2. And then I also had a 1 here, so 1 minus 1. And then I can simplify this. I can write 2 over 4 as 1/2. A, you can put the 1, you don't have to put the 1. B to the third. And C to the 1 over C to the 1, anything over itself becomes 1. You can write C to the 0, which also becomes 1, so we don't need to write that. And then finally, letter C, I'm going to write all of my coefficients separately. And then I have, if you wanted, you could put a 1 down here. So I have 3 on the top. I'm actually going to expand this one so you can see what's happening. I have y to the third, x, y on the top, and then I just have an x on the bottom. So I can see here that I will get y to the fourth because y to the 3 plus 1, and then x divided by x eliminates. So 6 times 2 is 12. 12 over 18 becomes 2/3 y to the fourth. And when we start putting all those extra things in there, that's when it gets very tricky. So those are your notes for tonight. We'll work on it in class tomorrow.